Welcome back to the second part of the Collections Class Methods Challenge. I'm about halfway through building my card game, a poker game called 5 Card Draw. I've dealt the hands, but I haven't done anything with them. Before I do the evaluation of the cards in a poker hand, I'll create a new list for the remaining cards, the ones not dealt. I'll do this in my start play method in the poker game class. First, I'll create a couple of local variables. Cards dealt is just the player count times the cards in hand fields. Cards remaining is the full deck size minus the cards dealt. I'm going to use nCopies on the Collections class to create a new list. This is not the easiest way to do this, but I want to just revisit this method for a moment. I'll instantiate a new array list. Passing a sublist of deck to the constructor is probably the most straightforward way to do this, but instead I want to make a call to the nCopies method on Collections, passing it the number of cards remaining as the first argument and null as the second argument. This basically fills my list with the number of elements specified and null references. Why would I want to do this? Well, remember, if we just create an array list with no arguments, or a capacity only, that means we've only got a 0 element list. So I can't use the fill method on Collections or the replace all method on list to quickly populate the list with elements based on some function. I'll use replace all to show you what I mean. It will get the current index in the remaining cards list, then add cards dealt to that to pick the card from the full deck. I'll add a lambda expression that will loop through all the elements in my list, which currently consists of 32 null references, and print remaining cards. You might ask why I'm doing something so convoluted. Let me insert another statement on line 36, where I simply instantiate remaining cards to a new array list with a capacity of the remaining cards number. And I'll comment out line 37. If I run that now. I don't get an exception, but I also don't get remaining cards printed either, and that's because I'm trying to use replace all on an empty list. If you plan to use replace all with a function that would make your code simpler, then this option using nCopies to fill the list with nulls is one way to prevent the empty list scenario I just showed you. Let me revert those last two changes. I'll remove line 36 and uncomment line 37, running that code with 4 players. I get 32 cards as the remaining cards because I used 20 cards for my 4 players. It's true, I could have just passed the sublist of deck to the array list constructor, but since one of my objectives was to use as many methods as possible on Collections, I thought I'd revisit that particular one. Okay, so lastly, I'm going to write the code that can evaluate each player's hand. In a real game, you maybe would only do this if you had some automated competitors, or if you're teaching someone how to play. I'm going to evaluate only half of the valid hand ranks, the ones associated with duplicate face cards in a hand, for simplicity. Getting back to the poker hand class, I want to create a method called setRank. This will take an integer parameter I'm calling face count, which is the frequency of a face card. For example, how many kings are in my hand? I'll use that to determine the ranking and score of the hand. I'll start with a switch on the method argument. Case 4 means I have 4 of a kind, so I'll set the score to that rank. Next I want to look at case 3, meaning I have 3 of a kind, but if I've already found 2 of a kind, then I have a full house, which is both 3 of a kind and 2 of a kind in the one hand. I will check if the current score is none, and if it is, I'll set the score to 3 of a kind, otherwise I'll set it to full house. Similarly, when I find 2 cards that have the same face card, I want to check if some other match was found. First, I'll check if the current score is none, which means this is the first pair found, so I'll set the score to 1 pair. Next, I'll check if a 3 of a kind was already identified in the hand, and if so, I'll set the score to full house. Otherwise, this means I have 2 pairs, and I'll set the score to that. Now that I've got a method to set score, I can set up an eval hand method. This is going to be a public method that takes no arguments and returns no data. I'm making it public because I may want to allow clients to use it. The first thing I want to do is create a list of strings. I'll call it faceList and make it the same size as the number of cards in a hand. I'll use the forEach method on hand to loop through each card in the hand and populate the list with the faceList card attributes. Next, I'll create another list of strings, and this will just be the face cards, where multiples are found. Later, when I cover sets, I'll show you a simpler way to remove duplicates but for now I'll check if this list already has the face card using the contains method. If it doesn't, then I'll also use the frequency method on collections, passing it my face list and the current face value. This will let me check if this face card has duplicates, meaning the frequency is greater than 1. If both those conditions are true, then the face card will get added to the duplicate face cards list. Now that I have a list of face cards that have duplicates, I can loop through this list to start ranking my hand. I'll get the index of the first face card in the series of the group using the index of method on the face list. I'll assign that to a variable called start. The last index is the last face card in the series of multiple cards of the same face card value and retrieved using last index of. I'll call setRank, getting the number of cards of the same face value using simple math, so last minus start plus 1. I retrieve the sublist using the start and last indices I got. I'll add the sublist to my keepers list, which is the cards I want to keep in my hand. Okay, that's how I'm going to evaluate and score each player's hand. I'll get back to the poker game and the start play method. I want to go up to line 31, where I'm printing this out, and insert a new statement after that separator line before the for each call on poker hands. I'll set up a consumer lambda expression using a method reference for the eval hand method I just created, so poker hand : eval hand. After that, I want to change what I have in the call to the for each method on the next line to use the check hand lambda, chaining, and then to that with the method reference to print the hand. In a single statement, I can evaluate the hand and print it. It's time to run this code to check if it's working as expected. You can see the player's hands. You might have to run it a couple of times to see some interesting scores, but hopefully you can see 1 pair and 2 pair, and if I keep running it, I might get to see a 3 of a kind or a full house. I'll change my players to, let's say, 8 players in the game controller and run it again, which lets us see more hands. And I can keep running that until I see more interesting hands show up. I'll eventually get 2 pair and 3 of a kind. If you're lucky, you may see even better hands than that, like a full house or 4 of a kind. Okay, so this code meets all of the challenge requirements. Did you create a similar card game? Maybe you used a linked list instead and used some of its methods like pop or first to deal the hands. Did you go the extra mile and do something interactive with the console, letting your user determine the next play? For good measure, I'm going to populate the discards pile for each player. This will be a suggested list of cards to discard based on cards that aren't part of a card rank as well as lower ranked cards. I'll do this in the poker hand class. I'll create a new method called pickDiscards, private and void, with no parameters. I'll create a local variable called temp that will be a copy of my hand, so new array list, and pass it the hand. I'll follow that by calling remove all on the list, removing anything that's in the keepers list. This might be good enough in some circles, but you may not want to throw away higher ranked cards, like an ace or king, so I'm going to check for these scenarios. I'll set up a local variable for how many of my cards are part of a card rank, and I'll call that ranked cards equal to the size of keepers. I want to reverse the order of my temporary list of remaining cards using collections.reverse so that the lowest ranked cards are first. I'll set up a local variable index starting at 0, then loop through each card in the temp list. I only want to add the card to the discards pile if I don't yet already have 3, and if the number of ranked cards is 3 or more, or the rank is less than 9. Otherwise, the card gets added back to the keepers pile. I will make a call to this at the end of the eval hand method. And running this code now, you can see the preliminary recommendation of cards to discard. Maybe you do this for the hands that are automated, or if you're teaching someone new how to play. For hands that are 2 pair, you'd only have 1 card in the discard pile because you'll want to keep both pairs presumably. For 1 pair hands, you'll have 3 cards to discard, but cards that are 10 or higher won't be included in the discards. Finally, I want to use the min and max methods on collections to print the hand's highest and lowest cards. I could do this by just getting the first and last card in my sorted hand. That's true, but let's imagine we have a different way of evaluating this and want a different order. I'll go to the toString method on my poker hand class. I'll add some additional text to the format string and 2 specifiers and I'll insert those before the final %s specifier, so best colon % minus 7s and worst colon % minus 6s. And I'll add 2 more variables in the list passed right before the discards part. The first we'll call collections.max, passing the hand but sorting by rank only, and then I'll call collections.min with the same sort. And if I run the code now, you can see the best card and worst card listed there. In some card games, one suit may rank higher when it becomes a trump suit, for example, and you might need another way of determining what the best card in your hand is. Okay, I'll end this challenge code here. I tried to use as many of the collections methods as possible, even in cases where maybe their use was questionable, but I wanted to give you a good review of this class. I used shuffle reverse, min and max, end copies, frequency, and rotate in this code. Perhaps you found ways to use swap or index of sublist, for example. If you came up with something you think other students might like to see, please feel free to share in the Q&A section of this video. Moving on now, in the next several videos I'm going to be switching gears and covering sets and then maps, the other 2 major categories of collection classes.